Here we have the infinite series n factorial divided by n to the n, and we want to show that this series converges. And so recall that in an earlier proof we have shown that the limit of 1 plus 1 over n to the n as n approaches infinity. But 1 plus 1 over n is the same as n plus 1 divided by n, and we have shown that this is the limit here is e, and again e is 2.71e, 2a, 1a, 2a approximately. But back to our problem, we want to show that this infinite series here converges using the ratio test, and so a sub n, it will be n factorial divided by n to the n, and then a sub n plus 1 is in the place of n, we have n plus 1, so n plus 1 factorial, and then divided by n plus 1 to the n plus 1. And then now we need to find the limit of a sub n plus the limit of a sub n plus n plus 1 over a sub n. So we need a sub n plus 1 over a sub n. That, and then times the reciprocal of the n factorial over n to the n. And now let's rearrange things a little bit more. So this is the same as n factorial, n plus 1 factorial, and recall that this is n plus 1 times n times n minus 1, n minus 2, all the way down to n. And then this is just this. And then let's rewrite this one also. N plus 1 to the n plus 1 is the same as n plus 1 to the n times n plus 1 to the first. So all of this will get cancelled out. And then this n plus 1 and this n plus 1, that will also get cancelled out. So what's left is just this. N to the n, and then n plus 1 to the n. And then we can rewrite this like this. And then this looks almost like the like this right here, except is upside down, except this one is n plus 1 over n. The limit here we get e, but this one is upside down, so we can do the reciprocal. So this is the same as the n plus 1 over n to the negative 1. And then negative 1 times n, it is negative n. Negative 1 we can actually we just move n inside and then move the negative 1 outside, and then this becomes and then this is the same as this. So we get e to the negative 1, which is 1 over e. And so we have shown that the limit of a sub n over a sub n plus 1 over a sub n converges. The limit is 1 over e, and therefore by ratio test this series right here converges. And recall that the ratio test says that if we can show that the limit of a sub n, the limit of a sub n plus 1 divided by a sub n is less than 1 as n approaches infinity. And here we have shown that the limit of a sub n plus 1 over a sub n is equal to 1 over e. And recall that e is 2.71828, so 1 divided by e is less than 1. And therefore this infinite series right here converges by the ratio test.